Okay, so now let's work through an actual example or two. In this example, two different brands of cigarettes are selected, and a sample of each is tested to determine its nicotine content. The results are shown below. Is there enough evidence to conclude at alpha equals 0.05 that brand A is lower in nicotine than brand B? So what happened was they got a sample of 30 brand A cigarettes, and those 30 cigarettes had an average nicotine content of 28.6 milligrams. And they got a sample of 40 of the brand B cigarettes. And those 40 brand B cigarettes had an average nicotine level of 32.9 milligrams. So we did see a lower average nicotine level in brand A in the sample than we did in the sample of brand B. We want to know if that's enough of a difference that we can say that brand A is lower than brand B in general, not just those particular 30 or 40 cigarettes we happen to study, but all of brand A versus all of brand B. Is the population mean lower for brand A than it is for brand B? So can you see what the claim is that we are testing here? The claim is that brand A is lower than brand B. So that means that mu1, the average nicotine level for brand A, is less than mu2, the average nicotine level for brand B. And this would be the alternative hypothesis. So the null hypothesis would be the same thing but with an equal sign, mu1 equals mu2. That would be that there isn't a difference in their nicotine content. Okay, step 2, compute the test value. If we're doing it using this formula, and remember I said the mu1 minus mu2 part of the formula was just 0, so really we'd just be calculating x bar 1 minus x bar 2 over the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. And this is what that would look like. So let me show you how that looks on an actual calculator. So I'm going to put it in as parenthesis 28.6 minus 32.9 close parentheses divided by the square root of parenthesis 5.1 squared divided by 30 plus 4.4 squared divided by 40. Close the parentheses under the square root sign, hit enter. That doesn't look right. Okay, what did I do wrong? That's not the correct Z. Oh, I added instead of subtracted. No wonder that was wrong. Okay, change that plus to a minus, hit enter. That's more like it. It's negative 3.699 something, about negative 3.70. Now, if you were using the special built-in calculator function, here's how that would work. You would push the stat button, go over to tests, and select 2SAMP Z test. That's number 3 on at least this model. Then you have to be on stats. So if you're not already, go over to that and select it. And it has places for you to fill in numbers for sigma 1, sigma 2, x bar 1, n1, x bar 2, and n2. So those numbers were Sigma 1 was 5.1. Sigma 2 was 4.4. X bar 1 was 28.6. In 1 was 30. X bar 2 was 32.9. And in 2 was 40. And I have to tell it what my alternative hypothesis looks like. Do you remember it had a mu1 less than mu2? So I got to select that. And then if I go down here to calculate, it tells me that z equals negative 3.699 and so on. And it also gives me the p-value here. P is 1.08 and so on. E minus 4, so that's scientific notation. That means move the decimal point 4 spaces to the left. So the p-value is really 0.0000108 and so on. And we could do this using that p-value calculator for Excel that I said you could download from Canvas and open in Excel. So make sure you're on the tab labeled 2SAMP Z-test. It's going to look something like this, and the yellow boxes are where you type in the numbers from your particular problem. So in the example we were working on, Sigma 1 was 5.1. Sigma 2, 4.4. X bar 1 was 28.6. X bar 2 was 32.9. In 1 was 30. In 2 was 40. And it tells us that the test value z is equal to negative 3.699. And if the alternative hypothesis is mu1 less than mu2, which is what we had, the p-value is 0.000108. Okay, now we're ready to make the decision to reject or not reject the null hypothesis. Oh, now what if we had used the formula and we were trying to get the p-value from that? We'd have to go to table E. Normally we'd look up negative 3.70, but that's off the charts. That's past where the table goes. So all we know for sure from the table is that the p-value is really, really small. It's less than 0.0003. But that's enough. The p-value is 0.000108, or if we didn't know that, we'd at least know that it was less than 0.0003. The alpha, the level of significance, was 0.05. And since the p-value is less than alpha, we reject the null hypothesis. So what does that say about the claim? The claim was the alternative hypothesis. We rejected the null hypothesis. So we can say there is enough evidence to support the claim. Rejecting the null means supporting the alternative, which was the claim, that brand A is lower in nicotine than brand B. Okay, one more example. A consumer group is testing camp stoves. To test the heating capacity of a stove, it measures the time required to bring 2 quarts of water from 50 degrees Fahrenheit to boiling. So how long does it take for each stove to boil 2 quarts of water? That's the measurement of how good the stove is. 2 competing models are under consideration. 10 stoves of the first model and 12 of the second model are tested. You can see that here. In 1 is 10 and in 2 is 12. The following results are obtained. So for each model, we have the mean time that it took for that sample of stoves to heat the water. And we have the population standard deviations. Assume that the time required to bring water to a boil is normally distributed for each stove. Is there any difference either way between the performances of these 2 models? Use alpha equals 0.05. Okay, step one. What they're asking is there any difference either way between the performances of these two models? If there is a difference, that means mu1 is different from mu2. The average time for one model is different from the average time for the other model. If there's no difference, mu1 is equal to mu2. So the one with the equal sign is the null hypothesis. The one with the does not equal sign is the alternative hypothesis. Step 2 and step 3, we got to put these numbers into either the formula or the graphing calculator or the Excel spreadsheet. This time I'm just going to use the spreadsheet, but you can use whichever method you want. So sigma 1 was 2.5. Sorry, that doesn't go here. It goes in this yellow box here, 2.5. Sigma 2 was 3. X bar 1 was 11.4. X bar 2 was 9.9. In 1 was 10, and in 2 was 12. So the test value turns out to be 1.2792, about 1.28. And since the alternative hypothesis was that mu1 is just not equal to mu2, the p-value is 0.2008. That's also what we would get from the formula, and there's the p-value. So in step 4, the p-value is 0.2008. The alpha, the level of significance, was 0.05. The p-value here is greater than alpha. We have a fairly big p-value, so we do not reject the null hypothesis. Remember what we were trying to figure out. Is there a difference between the performances of these two models? We did not reject the null hypothesis. So there is not enough evidence to say that there is any difference. We can't rule out that they really are the same in general, and the difference that we saw in our sample was just due to sampling error. So there might be a difference, there might not. We just didn't have enough evidence to say that there's any difference between the heating capacities of the two models. Now, on the notes from this section, there is a page called Now You Try that looks like this. So if you want to see if you've got the hang of this, try working through this problem. You can fill in all the blanks and then check your answers against. I will post the correct answers on Canvas. You can look at what I have and see if it matches what you have. And if not, you can try and figure out what you should have done. And if you still can't figure it out, ask me. So that's it for hypothesis testing.